Alrighty, now it's time. Instead of taking indefinite integrals, it's time to take definite integrals. And to evaluate them, we can use the fundamental theorem of calculus. So what we have for part A is the derivative from 0 to 1 of 4 minus the square root of x, the entire quantity in parentheses squared dx. Let's do that one first. Aha! We need to see that this is indeed a definite integral. It has limits of integration. Therefore, what does that tell us? It tells us one very important fact. Our answer will be a real number. It will not have a constant c. It'll be a real number. So this integral is equal to the integral of 4 minus square root of x times 4 minus square root of x. I'm simplifying it because it's too complicated the way it came. And when I FOIL that, I get 16 minus 8 square root of x plus x. Now I can integrate piece by piece across each of the terms. So the antiderivative of 16 is going to be 16x. The antiderivative of 8 times x to the 1/2 is x to the 3/2 times 8 in the front times the reciprocal of 3/2, 2/3, and that makes 16/3. And then finally, the antiderivative of x is 1/2 x to the 1/2. And now I evaluate that at x equal 1, and then subtract the evaluation at x equals 0, and you'll get 16 times 1 minus 16/3 times 1 to the 3/2 plus 1/2 times 1 squared. So 16 minus 16/3 plus 1/2, get a common denominator 6, and combine across the top, and you'll end up with 67 over 6. Now, I didn't show all the details there, but it's just the application of capital F of 1 minus capital F of 0. Let's do the second definite integral. It's the integral from -1 to 2 of -1 over t plus 2 squared dt. Let's bring we'll rewrite it in our head as t plus 2 to the -2. In other words, we'll flip it upside down. And it still has a negative sign in front. We're ready to take the integral now because we see it in the form of an exponent. And that will give us, let's see, the antiderivative. The antiderivative will be introduce 1 to the exponent, and that'll be -2. I'm doing this in my head. -2 plus 1 makes -1. And then multiply by the reciprocal of -1, that is -1. Bring the -1 out in front, multiply it by the negative sign that's already out there, and you get a positive parenthesis t plus 2 raised to the -2 plus 1, which is -1. So the antiderivative of the negative t plus 2 to the -2 is t plus 2 to the -1. I'm sorry, the antiderivative of negative t plus 2 to the -2 is equal to t plus 2 to the -1. That's our capital F of t. Now evaluate that for the limits 2 to 1, and we'll get positive 2 plus 2 to the -1, and then minus 1 plus 2 to the -1. That's capital F of 2 minus capital F of 1. That simplifies to 1/4 minus 1/3, which is 3/12 minus 4/12, which is -1/12. So we see here that we had both of these examples, A and B, were actually difficult functions from which to derive the antiderivative. So we had to go kind of slow and simplify the integram before we could actually see how to find the antiderivative. And once we found the antiderivative, we were able to evaluate it at the upper limit minus the evaluation at the lower limit. In other words, capital F of B minus capital F of A, and then get our number, our real number solution to our definite integral.